So in the previous video, we took a look at the ROM board that we designed and wrapped using 2716s for the AppleSoft Basic, and the language card and the conflict, I believe, that is happening, keeping the machine from being able to boot ProDOS. And we came up with a couple of minor changes here to this design that involve disconnecting where the card can express inhibit itself. So we're going to disconnect this and then actually using the inhibit that comes in on the bus, in this case from the language card, to actually inhibit this card from working. And it's a couple of pretty minor little changes, assuming I can get to the wraps. I'll comment here that we did the entire data bus in blue and then the address bus in yellow. Then we moved on to the brown for the control signals. One of the reasons I did the control signals last is it's the most common thing that gets modified as functionality evolves on the card. And rather than trying to dig brown wires out from underneath yellow and blue, I worked from the things that are the most common: power, and then data and ground, or power, then data, then address, and worked my kind of way up through the layers. So first thing we want to do is remove the wrap on pin 32. So there is +5, 27, 28, 29, 30, 31, and 32. I have trimmed that pin down. 32. Is that really 32 there? Power. 27, 26, 25, 24, 23, or 32. 27, 28, 29, 30, 31, 32. It looks like this wrap right here really is the correct wrap to remove. I'm using an unwrap tool here. It's actually fairly close to the top here, which is handy. Let's see if we can find it. There's a little loop of wire here that kind of works as organization that I may have to cut and release. Oh, I've got such a mess here on the bench that finding anything at the moment is going to be difficult. I don't think those are going to get in there the way I need to. Like I said, there's just a little loop of wire here that does nothing but help organize. Well, it helps hold in place, the wiring mess here. I'm going to go ahead and attempt to remove that, which we just did. This will make it a little easier to trace this wire on through. That wire should go to the LS09 pin 6. LS09 I think is right there. Pin 6. I can actually see it flexing there. There's a single wrap on that pin, so it should be the same wire. And we've successfully unhooked this. Now what's going to be a little trickier is I've got, where did it go? Pin 10 and 11 are actually wired together on the 74 LS11. And the 11 is sitting right here. And I'm sure there's just going to be a little loop of wire between the two. 3, 6, 7, 8, 9, 10, 11. It's going to make that a little difficult to get into. It's that loop right there. The problem is I've got... Why would I have two wraps coming to that? That's why. So actually 8, 9, 10, 11. I'm going to have to 8, 9, 10. That should be the LS11. I'm going to go ahead and pull this one off. get a hold of it. Because that wire will be replaced. 8, 9, 10, 11. This lead gets pulled off, and that daisy chain's someplace. Where's that wire going to? As you can see, this can get a little bit tricky. It looks like it's there. I'm confused why it's running over to pin 13. That's why. Okay, so it should be going to pin 13 into 2, so that is correct. It goes to 13 and 2. And is it the top wrap or is it the bottom wrap? It's the bottom wrap, damn it. So I want that wire to go to pin 10, 8, 9, 10. But I need to unwrap 10 and 11, which are still connected together. That was the whole reason we tore this down this far. 8, 9, there's 10 coming off. I didn't unwrap it all the way. Oh, doggone it. There it is. Okay, 10 and 11 are separated. I want this wire to go back to 10. The problem is the where it's located in the wrap, I'm going to end up undoing much more wire than I want to here to get this into place. And I'm going to cheat here and attempt to reuse the wire that I've previously used. I've had luck with this in the past. Obviously, it's not going to be the most reliable way of doing things. So there's 8, 9, 10. Let's see if we can get a good wrap with it. That lead is going off to where? That lead confuses me. That lead runs off to interrupt in. Does that make sense? I need better light. I'm struggling a little bit to see. This lead that we pulled off does go to pin 28, interrupt in. doesn't make sense. Why would it be? That doesn't make sense that this wire would be loose. It really doesn't make sense to me at the moment. I have done something obviously wrong here. That really does go to or is it going to DMA-in? It's going to DMA-in. That's my confusion. DMA-in. So that also goes to pin 10 on the same IC down here. Okay, that makes more sense. So by going to pin 10, DMA-in, to pin 10, we get it connected also, so we complete that whole chain. So I'm going to, again, cheat and reuse the wrap wire. As soon as I find the tool. Well, I think I'm going to. And the problem here is, this again, lead is the lower one on the other wrap, which means I'd have to release another wire to release this one. And the whole problem just becomes harder and harder to deal with. See if we can get that to pin 10. Eight, 9, 10, which is right here. And then we're going to take pin 11. Maybe, if I can see. That is this pin right here. And I'm using yellow, which I probably shouldn't be using, but it's the color I have at hand here. And that's going to come over to pin 32 to pick up inhibit. Power 27, 28, 29, 30, 31, 32. Okay, it's where I thought it was. Oh, these nippers are shot. Those are absolutely shot. Power 27, 28, 29, 30, 31, 32. And that completes this joint right here. So what we should have now, let's tap it out and take a look, is I should have pin power 27, 28, 29, 30, 31, 32. Should come to pin 7, 8, 9, 10, 11. Okay. And then we should have DMA-in, which is on 27. So 27 is up here, DMA-in. I need to get the schematic so I can see it because it goes to several places. DMA-in is right here. And that runs to pin 10. 8, 9, 10. Runs to pin 10. And runs to pin 13 and 2. 13 and 2. That looks correct. We should not have continuity between 27 and 32. And we do not. I would say we've been successful in modifying this to receive the inhibit signal rather than generate the inhibit signal. And maybe now it'll work with the language card. We'll find out. So I'll see you downstairs. So we've made the wire wrap changes to the card, and we've got the card inserted back in the system. We've got the language card in place. The DRAM's been removed, added to the card, and the ribbon cable plugged in where the DRAM was. We've got our CFFA3000 here, and it's currently set to boot. ProDOS 1.9, I believe, is the image. So we can go ahead and power the Apple II up here. And we get the garbage screen. Let me reset, and we'll jump into the CFFA menu. And we can go ahead and look at the disk assignment, so we can see that I've actually got ProDOS 2.0.3 mounted, which is fine, because this demonstrates at least this combination of hardware is trying to work. So if I do a Control-B here to boot, it'll attempt to boot it. It'll tell us, P2 DOS 8 version 2.0.3. It also tells us it requires an Apple IIe or later, which we don't have. Before, we were getting that relocation error. So we're getting past that relocation error, and it appears that the system is recognizing the memory on the card along with the ROMs, sitting parallel, sitting in the same address space. So this looks like it resolved the issue with Inhibit, which is pretty cool. So is there anything else I can do here at this point? I can't reset and get back into the menu. Anything else to demo? I don't think there is. I think this just shows that that wire, that change worked. Allowing the card to see the Inhibit line rather than drive the Inhibit line and then use the Inhibit line to disable itself when this card's calling for the bus has worked. This combination and the way I've got it wired works because there's no ROMs in the sockets down here on, just bumped the camera, on the motherboard itself or the main board itself, which is why this mod works. So if I can ever find a ProDOS bootable version, I will. I've looked at a whole bunch of different versions so far, and I'm having issues with the image file types and converting between file types, etc. But I'm confident once I find something that's correct, the system should boot and run ProDOS. It looks like ProDOS 1.1.1 was the last version that supported the Apple II Plus. I've only been able to find SHK images, I think, shrink images that the CFFA card doesn't seem to recognize. I've converted those to .pl images. It boots, but it gives me an error about system file not found. And that's a different problem from this. Anything else ready to say here? I don't think so. I think we have successfully modified our design and made further progress. So with that, I'll wrap this video up, and I'll see you in the next one. We'll talk soon.